Good day, class! Today, we will hop on to our next discussion under physics. Growing up, we all have these questions in our mind while observing different natural scenarios that happened around us. What is happening? Why did it happen and how did it happen? At some point in time, our curiosity gets the best of us. Behind all these things that we see, we do, and we experience every single day, there is what we call the world of physics. A world that is more than what meets the eye. So as we enter this world, we will first encounter the most common topic under physics, the laws of motion. Pero bago ang lahat, I would like all of you to meet the man behind these laws. He is Sir Isaac Newton. Kilala siya for publishing and producing Principia, which is the summary of the Newton's laws of motion na aaralin natin today. He specifically produced Principia in the year 1687. Without further ado, let's talk about the Newton's first law, which is the law of inertia. Sabi sa first law na ito, an object in motion will remain in motion and an object at rest will remain at rest unless acted upon by a force. So in other terms, wala raw mangyayaring pagbabago sa bilis ng isang bagay hanggat walang puwersa na ini-a-apply dito. Para sa mathematical representation ng first law, makikita natin ang F-net or net force na 0. Net force is the initial force or yung force na kailangan nating i-apply sa isang bagay. So, 0 ang net force. Kapag 0 ang net force, 0 din yung acceleration. Yung acceleration is yung pagbabago sa speed nung ino-observe natin na bagay and the velocity naman will remain constant. So, that is the mathematical representation of our Newton's first law. Let's take this soccer ball as an example. Initially, it is at rest, so it has 0 acceleration and 0 velocity. 0 din yung net force dahil wala pa namang ina-apply na force sa kanya. So, sabi sa Newton's first law, itong bola daw na ito ay hindi gagalaw. Mananatili lang siyang ganyan hanggat walang net force na i-apply sa kanya. So, sabihin natin biglang may dumating na soccer player. Nakita ng soccer player yung itong soccer ball natin and sinipa niya itong soccer ball natin. So, yung pagsipa ng soccer player ay yung magsisilbing net force na in-apply sa ating bola na magre-result sa paggalaw ng ating soccer ball. So, that is the concept of our Newton's first law, which is the law of inertia. Let's proceed with the Newton's second law, which is the law of acceleration. Sabi naman dito sa second law, the amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the body. It is mathematically expressed as F-net is equal to mass times acceleration or MA. In other words, ang pagbabago sa bilis ng isang bagay ay nakadepende sa net or acting force, which is sabi natin kanina ay yung force na ina-apply sa isang bagay at sa bigat ng bagay na yon. Merong sinabi dito na proportional to acting force. Ibig sabihin, pag mataas yung acting force, mas mabilis yung magiging acceleration ng isang bagay. And yung last part, which is yung inversely proportional to the mass of the body, ang ibig sabihin naman nun, kapag mas mabigat yung mass ng bagay na yon, magiging mas mabagal yung acceleration. So, ayun yung dalawang components na nakakaapekto sa acceleration natin. These are the acting force or yung net force at yung mass of the object or the body. Okay, so halimbawa meron tayong dalawang bola. We have a soccer ball and the other one is a bowling ball. A soccer ball has a mass of 0.5 kilograms habang yung bowling ball naman natin ay may bigat na 3 kilograms. Suppose, sisipain sila ng sabay with the same amount of force na 0.7 kilogram times meter per second squared or Newton. We can observe na mas nagiging mabilis yung soccer ball kaysa sa bowling ball. So bakit? What is the reason behind it? Sabi sa Newton's second law, nakaka-affect sa acceleration ang acting force at ang mass. So kahit na equal amount of force ang ina-apply natin sa soccer ball at sa bowling ball, nagiging mas mabilis yung soccer ball natin dahil mas magaan ito kaysa sa ating bowling ball. Ganon yung sinasabi ng ating law of acceleration or yung Newton's second law natin. Pwede din nating i-prove ito mathematically gamit yung mathematical representation ng Newton's second law, which is yung F net equal to mass times acceleration. With this formula, pwede natin itong isulat as acceleration equal to net force divided by mass. So, nilipat lang natin yung mass sa kabila and isolve natin yung acceleration ng dalawang bola with the given amount of force with their respective masses. So, for the acceleration of the bowling ball, we have A equal to 0.7 kilogram meter per second squared, the acting force, divided by 3 kilograms, which is the mass of the bowling ball. With that, we will get the acceleration of the bowling ball, which is equal to 0.23 meter per second squared. Para naman sa acceleration ng soccer ball natin, same procedure lang din, pero ang gagamitin natin for the mass ay yung mass ng soccer ball. So, A equal to 0.7 kilogram meter per second divided by 0.5 kilograms, which is yung mass ng ating soccer ball. With this, we will get the acceleration of the soccer ball, A equal to 1.4 meter per second squared. So, comparing the two values of accelerations, the acceleration of the bowling ball and the acceleration of the soccer ball, mapapansin natin na mas mataas yung value ng acceleration ng soccer ball kesa sa acceleration ng bowling ball. That is our Newton's second law. Last but definitely not the least is our Newton's third law, which is the law of reaction. This law states that for every action, there is an equal but opposite reaction. So, para ma-observe ang law na ito, we need at least two objects. Kaya yung mathematical expression ng law na ito is yung nasa baba. Let's have an example right away. Suppose we have a chair and a man. So, the man sits on the chair. In this scenario, we can already observe the Newton's third law. Paano po, ma'am? So, though hindi natin nakikita, meron kasing force of gravity na humihila dito sa lalaki against the chair. On the other hand, meron din namang equal but opposite na force present, which is yung force ng chair against the man. So, meron tayong dalawang force na present dito. They are equal forces but opposite in direction. So, what if wala yung equal but opposite force na ito ng chair? Anong mangyayari sa scenario na ito? Once na mawala itong equal but opposite force na ito, mawawalan ng equilibrium ang chair at ang man. So, mawawala yung equilibrium sa scenario na ito. Pag puro force na lang ng gravity yung matitira, magko-collapse yung upuan at malalaglag yung lalaki sa pagkakaupo nito. So, that explains our Newton's third law of motion, which is the law of reaction. So, ayon yung tatlo nating Newton's laws of motion. Let's jump right through our discussion about light. Light is a natural agent that stimulates sight and makes things visible. We have here some examples of sources of light, the sun, and a light bulb. Usually, kailan ba natin ginagamit ang light bulb? At nighttime, di ba? Kapag wala ng light from the sun in our place. We use sources of light like this para mas makita natin yung mga bagay around us. Questioning the characteristics of light, some people say that light is a particle, katulad ng mga atoms na inaral natin noon. May iba naman na nagsasabi na light is a wave, just like what we see in water or in this illustration, in this picture sa kanan. Para mas ma-analyze natin ito, alamin muna natin kung ano ba yung particle at ano ba yung wave. Wave, by definition, is a disturbance that propagates through space and time. It involves the transport of energy without the transport of matter. Basically, ang wave is a series of movement of energy from one place to another. So, ganun yung isipin natin. So, wave, it is a movement of energy from one place to another. For the composition of wave, we have the wavelength, which is the distance of one peak to another peak, or yung pinakamataas na height ng ating wave. In the illustration, we have short wavelength and long wavelength. So, kung mapapansin nyo, mas wider yung long wavelength kesa sa short wavelength. We also have frequency. Ito namang frequency, this is just the number of waves that passes through a certain point. As we can observe sa illustration, pag mas short yung wavelength, mas nagkakaroon tayo ng higher frequency kasi mas maraming waves yung present compared sa long wavelength na konti lang yung waves. Okay, ang particle naman is a relatively small or the smallest discrete portion or amount of something. So kapag meron kang object and na-dissect mo yung certain object na ito into smaller parts, matatawag mo daw iyon na particle. A good example of a particle is sa atom. So, napag-aralan natin noon na meron pa itong mga subatomic structures na tinatawag din natin na subatomic particles, which is yung smallest part nung ating atom. Now that we know what a wave and a particle is, let's face the big question for our topic for today. Is light a wave or a particle? The answer is both. Light is a wave and at the same time, light is also a particle. So, paano nangyari itong dalawang ito? Let's talk about light as a wave first. So, meron tayong illustration dito ng electromagnetic spectrum. Itong electromagnetic spectrum na ito, ipinapakita nito ang light sa iba't ibang wavelengths. Light will appear violet if the wavelength of the light is super short. Pag nag-increase ng kaunti doon, yung wavelength, light will appear naman as blue. Then mag-increase ng kaunti, it will appear as green, then yellow, and so on. Malalaman natin na ang wavelength ng light ay mahaba kapag na-observe natin na ang kulay ng ating light is from orange to red. So, this is how we see light as a wave. For light naman as a particle, so sabi natin kanina, a particle is a relatively small or the smallest discrete portion or amount of something. Suppose we are in a dark room and the room has a hole in its wall. Since umaga sa labas, the sunlight will enter our dark room through the hole. Itong light na ito na nakikita ng mata natin contains smaller parts na bumubuo sa kanya in a microscopic level. So having said that, light is composed of smaller parts, so we consider it as a particle, specifically a massless particle. So ganun natin nakikita itong light as a particle. Those are the reason why and how we considered light as a wave and as a particle. Now we know what are the Newton's laws of motions are, and we also understand their concepts. We also learned the duality of light being a wave and a particle. So that is it for our discussion about the last module for physical science. See you around. Ingat kayo lagi.